Hello everyone. Today's little video is going to be on multiplying and dividing fractions. And when we multiply and divide fractions, it's different than adding and subtracting fractions because we do not need a common denominator. So it makes it a lot easier to solve these types of problems with fractions. So my example to start out with is 2/3 times 3/4. Because there is a multiplication sign between the fractions, that does not mean that we're looking for equivalency. So we're not going to go diagonally and multiply opposite numerator and denominator like with cross multiplying. That would be if there's an equal sign here. This is multiplication. So with multiplication, we simply multiply across. So sometimes you will see it look like this. It's 2 times 3, the numerators, and 3 times 4, the denominators, and you would get an answer of 6/12. Now that would be a value that is correct, but it is not in simplified form, which most fraction answers should be. Now in lower classes that you would have first learned how to multiply or add or subtract fractions, a lot of times you could leave them in any form that you got an answer in. But as you advance in math classes, you should always try to simplify them down as much as they can so it makes more sense. Because if you have a big number with a lot of digital value, you just can't compare the two as easily as if you can simplify them down. So 6/12 can be simplified down. If we took a 6 out of both numerator and denominator, which is actually the value of 1. We've talked about this in simplifying fractions, that you can divide by 1, you can get the same value. So that would be then 1/2, as 6/12 being simplified to the simplest akin to 1/2. Now, another way you can look at when you multiply fractions is that if I can look at the fractions and simplify, or the factors and simplify them down before I multiply, you may get to this simplified answer quicker or easier sometimes if these numbers become very large in your answer. So 2/3 and 3/4. It's the commutative property that we look at. So if I just look at 2 times 3, which is 6, and if I flip those factors around to 3 times 2, I still get 6. That's the commutative property of multiplication, and it also works with addition, that you can switch the factors or the add-ins around and still get the same answer. And that's what we're looking at here when I look at simplifying these two factors before we multiply. 2/3 can't be simplified any farther. 3/4 can't be. But if I switch that numerator around and flip the 3 and 2 around, do I then have something I can simplify? Yes, because now 3/3 is actually canceled out to 1, so that is the value of 1, and 2/4 can be canceled or can be simplified to 1/2. Well, multiply across, now I've got my answer that I had here previously of 1/2. So you can flip your numerators around when you multiply, and you can see then if you can still simplify any of the factors out of any fraction now that you have as factors for the multiplication problem. And if you can do that, then you can get to your answer that is in simplest form. Once these are simplified as far as they can in the factors, you cannot simplify that answer down any farther. It will not come down anymore. Don't have to worry about it as long as these are simplified as much as they can be. Another quick look before we move into dividing is that some people, once they understand that you can interchange those numerators and switch them around, a lot of times you can look diagonally because we had 2/4 and we had 3/3. So if you look diagonally with this multiplication sign, you can see that these will cancel to 1, and you can take a factor of 2 out of here, and you can then also see then that is 1/2 as an answer. So instead of switching these physically around, which is okay to do, you can just look diagonally and see if there's any factors of both of those that can come out to simplify your factors. Okay, so now let's move on to dividing. Dividing is a little different, but we're going to still use these two same fractions, and we're going to divide them now. So 2/3 divided by 3/4. Now, we have 3 steps when we divide fractions. We copy, we switch, and we flip. Those 3 action verbs have meaning to what we do when we divide fractions. When we say copy, switch, flip, it can be sort of a little catchphrase in your mind, but you have to understand what the copy means, the switch means, and the flip means. So the copy means copy first fraction, and what we mean is first fraction is always the one to the left as we read in English, left to right. So we copy the first fraction, we switch the sign. So and it's switching the sign to multiplication. So switching the sign from division to multiplication. And then my third thing I do is flip second fraction, or put it into its reciprocal. Reciprocal is switching numerator and denominator around. So we're going to flip the second fraction, or put its reciprocal down. And then it's simply just what we did before. We multiply fractions. So again, we multiply across, and we can get 2 times 4 is 8, and 3 times 3 is 9. Now, if I look at simplifying this down, before I multiply, 2/3 I can't do anything to, 3/4 I cannot, 2/3 I cannot, and 4/3 I cannot, because notice the 3's are the same in the denominator, so it doesn't matter if I switch the numerators, I'm going to have that same fraction. So there is nothing I can do. 8/9 is in simplest form for this answer. So multiply across just like normal once you have the 3 steps made of copy, switch, flip. So division can be very simple as long as I have that little catchphrase, copy, switch, flip, and you never flip the first fraction. It's always that second fraction that I flip and copy the first one down. I don't flip them both. So that's very important. You know what those 3 verbs mean, copy, switch, flip. Now, real quick, I would like to show that something that you never ever can do is never ever multiply and divide mixed fractions. I'm just sort of arrowing to multiplying and dividing. Never ever multiply or divide mixed fractions. So if I have 1.5 times 2, and let's go a half also, and if I was to multiply those, I do not multiply the 1 times 2 and the 1/2 times 1/2. I don't separate fractions and whole numbers. I have to have the whole value to multiply, which means I have to convert into an improper fraction. So 1.5 goes 1 times 2 plus 1 is 3/2. And then 2 times 2 plus 1 is 5/2. And then I can multiply, because now I have numerator, denominator, so 3 times 5 is 15, and 2 times 2 is 4. Now, do I need to turn that back into a mixed fraction answer? It all depends. It could say in the instructions you need to, or if you're measuring. You cannot have a measurement in improper fraction, because there's no such thing as like 15/4 of a cup. You can't have that, but you can have so many full cups and then partial cups. So I have to convert that if it's a measurement or if it's asked to in the instructions, such as some computer programs say it has to be a mixed fraction answer to solve it. But if we didn't have to, 15/4 is a fine answer, because again, 3/2 can't be simplified, 5/2 can't, 3/2, and 5/2, again, the 2's are the same. It didn't matter if I flipped them back and forth. So 15/4 is a fine answer. Now, if I did want to convert that, how many whole 4's go into 15? And that would be 3. And then 3 times 4 is 12. 12 minus 12 from 15, I should say, is 3 left over. So that makes that 3/4. So 3 and 3/4 is the same answer as 15/4. Either way is acceptable, but this is a fine answer again, as long as I don't have to measure or it says I need to do that. Now, if we divide, we're just going to change this sign. Let's divide those two fractions. Okay, again, I cannot say 1 divided by 2 and then 1/2 divided by 1/2. I have to go convert them into improper fractions. So again, we had 3/2 divided by 5/2. It's very important I copy that down as improper fractions from the mixed fractions, because don't sit there and combine these 3 steps of copy, switch, flip, and then I'll get confused. So if I just copy that back down as the problem to divide, now I can go through my 3 steps. So copy first fraction, 3/2, switch the sign to multiplying, and flip or find the reciprocal of 5/2, which is 2/5. Okay, now I'm ready to multiply, because that's what we do when we divide. We've switched it to multiplication. Now I can multiply and cross and get 6/10. That is not a great answer, because 6/10 can be simplified. And that simplification is I could take a 2 out of both top and bottom and get 3/5. Now that is the best answer you've got when it's simplified down. Now if I look ahead and go, whoa, can I simplify any of these fractions here as factors? Yes, I can, because 3/2 can't be, 2/5 can't be, but if I look diagonally, I can cancel these out to 1. And because of that, then I have 3 times 1, 1 times 5, and I get that 3/5 that I wanted after I simplify the 6/10. So either way, you can solve it without simplifying ahead of time, but it just helps you with easier math facts that you don't get into big numbers when you get into the final answer, that now I have to simplify that down. So if you can see it ahead of time, that's great. One key thing is, people will do this, that they see this as a problem and they might say, well, can I simplify this ahead of time? I can't, because it's a division problem. Commutative property doesn't work in division. So I can't look for simplifying here unless the fraction itself can be, but I can't look diagonally. I have to wait till I have the multiplication sign involved. Then I can do the commutative property of diagonally looking for simplification. But if any fraction itself can be simplified, go ahead and do it. It's a lot easier math facts to work with when you get to your final answer of not needing to simplify it possibly. Okay, that is sort of the wrap-up of multiplying and dividing fractions, whether they're improper, proper, or mixed. And to get to that answer, key thing with division is copy, switch, flip, and to remember those 3 steps and do them, otherwise your answer will be incorrect.